Hello, today we'll be doing number 4 of our Neetcode150. This is going to be group anagrams. In this particular problem, we are given a list of strings and we need to group these into anagrams. So bat goes with bat, and nat and tan uses the same character, so they're anagrams, and we need to group them together, and it is so here. And 8, eat, and tea uses the same number of characters, and we group them together here as well. So one way is to always look back at what we've done before, which is anagram, and there are multiple ways of solving this particular problem, and one of the ways was to use sorted. To get a quick solution out there, we use sorted as our key, a sorted array. And tuples can be stored as keys, as well as strings. So we could either use a join or use a tuple. And with that, by doing that, we can create this item and send it back out very quickly. Watch. So hash set is equal to a default dictionary of list. And for s in strings, or for each string, what we're going to do, we should use str if we want to be more, no we don't, because that's a important keyword. So what we're going to do is create a tuple of a sorted of this particular string, and this is going to dot append this current string. And we can return the hash sets immediately, dot values, and we have our solution. Submit. Okay, this was pretty quick today. Alright, so of course you can see the memory usage is 38%. It's pretty good, but then the runtime is O of n log n because of the sorted s problem. So let's define our anagram function, and this way we can return O of n time. So what we're going to return is a tuple of a string, int, right? And so what we're going to do is use an array of a 0 times, let's say, 256 items. And in our previous solution, what we did was for each character in the string, we're going to get the ordinate of that particular character and plus equals 1. Then we can return the tuple of that array, and we can run this function, self.anagram, and we can return the same answer. Oh, right, my bad. It's, we do it like this. So submit, and we will have a very poor solution. It's pretty slow, and we used a lot more memory. That's because for each tuple, we're using 256, ints for array as our key, and so we have to look through 256 items to get the same key. Now, if we reduce these numbers here, and we take an ordinal of a, and we reduce that by like 10x almost, what we are going to get is a much quicker time and space. So as you can see, it is now much faster because of the lookup time of keys. The one thing is, what we did earlier was even faster because it's only 10 to the 4th, so 10,000 strings long, and each string is only 100 characters, which we're sorting. So that did not affect us too badly. So instead of this, let's just return let's make a new algorithm, Anagrams 2. And what we're going to do is return the tuple of the sorted of string. So this means our tuple is of string. Instead, and anagram 2, run code, also works. And this is even faster and takes less memory. And the reason being is because we're using exactly the amount of memory needed for creating the key. Of course, the runtime is something else. Anyways, with that, I think we have gotten a pretty good understanding of how hash sets work in terms of keys and how to produce keys, and in terms of how big keys can be and how small keys can be can affect the runtime of your solution. I think that was pretty interesting. And if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.